everyone, and welcome to the Math 1 LS3 computer programming tutorials. In this video, we're going to talk about Euler's method and Riemann sums. First, when you open this lab, please take a look at the questions on your online assessment form. Also, please run the first cell every time you come back to the notebook. Make sure that the message comes up that says Lab 3. So what is Euler's method? Euler's method allows us to approximate a function based on its rate of change. It is important to understand the mathematical algorithm before you begin to code this. We will be using this variation in our codes. In this variation, each t is calculated by the previous t plus the delta t. Each y is calculated by the previous y added to the rate of change at that step times delta t. Before you go over the first question, please go over this example. In this example, you will be estimating the y function for this rate of change function that you're given. dy over dt, or the rate of change y prime, or g of t, is given to you, and y0 is your initial condition. Now we can take a look at the code to see how this is coded. Initially, we have to set up two empty lists for t and y. As we go over the steps, we are going to store our values here. N is the number of steps and delta t is our step size. t0 and y0 are the initial condition. These are added to the list using the append code. Euler's method is represented by this for loop. Each step is represented by I that goes from 1 to n, the number of steps. Similar to the mathematical formula, each t is calculated by the previous t plus delta t. Each y is calculated by the previous y plus the previous rate of change times delta t. These values are then appended to the list. An algebraic solution is available here. The solution is not available for any of the other questions. Then we are displaying the results using the print code. We are also displaying the algebraic solution and the difference between the approximation and the algebraic solution. Remember, this may not be the case in all the questions. The solution plot is made using the plotting codes. Before you work on the questions, it is important to note a few things. The function that you are given in each question, or your y prime, or your rate of change, goes into these brackets. In this question, this function is your rate of change, which is put into these two brackets. Remember to keep those brackets for all questions and put your function inside them. You can change your n and delta t to find y at time t. Remember that if you multiply those values, you'll get t. A smaller delta t gives you a better approximation. Remember that the algebraic solution is only available in this example. Remove everything with algebraic for the next questions because you're not given an algebraic solution for those. The next part of this assignment is about Riemann sums. Take a look at the endpoints of the rectangles that are used for the left and right sums. For each of these sums, there are 4 rectangles and 5 endpoints. Remember that the last endpoint isn't used for a left sum. Similarly, the first endpoint isn't used for a right sum. We can go through the code together to learn how each part of it works. First, define the interval that you're given using a and b. N is the number of rectangles that you'll be using. Then you can make an array of all the endpoints. Remember that your number of endpoints will be one more than the number of rectangles. We can simply calculate your y values at the endpoints by defining your function. Then you can calculate your delta x, or the base length of each rectangle. And finally, the areas, by multiplying y, the height of the rectangles, by the base length of them. Now that you have all the areas, you can calculate the left and right sum. Remember that the left sum uses all the endpoints from the first one up to but not including the last one. The right sum uses the second one and goes up to the very last endpoint. These are reflected in these codes. There is a second method for calculating the Riemann sums. Similar setup, you have to define your intervals, your x and your delta x. Here you have to make two empty lists that will be storing the y values for the left sum and the right sum. This time you'll be using a for loop to calculate this. Each loop goes through the values of x, finds the corresponding y values, and adds them to the y list. Finally, for the left sum, it finds the sum of the left values and multiplies them by delta t. It does a similar method for the right sum. You can also calculate the midpoint sum using this method. Remember that the midpoint sum uses the middle value of the rectangles, or the average of the two endpoints. Now you can work on your questions. For Euler's method, when you're entering the rate of change formula, make sure that you use enough brackets so you keep the correct order of operations. Also, do not miss any multiplication signs. Submit your answers on the online assessment tool. Thank you for watching, and let us know if you have any questions.